Okay. So functions, remember, are rules that give us outputs when we give an input. When we talk about the average rate of change, it's just giving us the specific interval of our input values. Okay, we're going to use our specific input of our intervals. So this first example has a table, and this is the time 15 minutes. It's the number of people that come into a movie theater 15 minutes prior to openings. So like before the movie starts. So 4 minutes after the doors have been opened, 32 people came in. 6 minutes after the doors opened, 54 came in. 9 minutes after the doors were open, 102 came in, so on and so forth. Okay. So the first part of this doesn't really even talk about average rate of change. It says, hey, can you evaluate this function? It's trying to remind you that you know how to evaluate a function. And this is the function n of 9 minus n of 4. What does that mean to do? Yeah, you find the output when n is 9, and you subtract it from the output when n is 4. So what is the output when I let n equal 9? Look at your table. What is the output when n is 9? Yeah, it's 102. What is the output when n is 4? So between 4 and 9 minutes, how many people entered the theater? What is 102 minus 32? 70. So in that interval of time between 4 and 9 minutes, 70 people entered the theater. We need to figure out the rate that the people enter the theater, and it's going to be in a total of like per minutes. So if in that time 70 people entered, how many minutes are between 4 and 9 minutes? How many minutes have passed? 5 minutes. Well, if I take 70 divided by 5, I find out that 14 people enter per minute. Yeah. So we're just finding the unit rate. That's really all it's asking us to do. It's just finding the unit rate. So that first one, it just kind of talked us through setting it up like a function. The second one says, okay, so we're going to take that time of 4 to 9 minutes, and we know that in 4 to 9 minutes, we get 14 people per minute. Which one has more people entering per minute? Between the 4 and 9 minute interval or between the 9 and 15 minute interval? So let's calculate how many people enter the theater between 9 and 15 minutes. So when I let n of 9, remember, what is that value? 102. N of 15, what's that value? 150. And we subtract those. God bless you. Y2, 150, God bless you, minus Y1, 102, over X2, 15, minus X1, 9. So let's see, 150 minus 102 is 48. 15 minus 9 is, and what does 48 over 6 reduce to? 8. So we have 8 people between 9 and 15 minutes. 8 people are entering per minute. Which one has more people entering per minute? Which interval? The 4 to 9, right? Because there's 14 people. So it's just calculating slope. 14 people per minute at 4 to 9 minutes. What's your answer? Oh my God. There was a bug on my water. I hate that. Okay. So can we go on to the next one? Flip over and we're going to talk about average rate of change. So the average rate of change is just the function specified over a specific domain. What does domain tell us? What does domain mean? Yeah, this is your X value. Oh my goodness. Or your input. It's your X value or your input. Mrs. Bischoff. Absolutely on his way. Thank you. William, down to Mr. McAllister's office, please and thank you. Okay. So for the function, so to calculate the average rate of change, here's what you're going to do. This says, remember the change in Y over the change in X, which is how much the Y values have changed over how much the X's have changed. That's what we've been doing. It's just calculating slope, right? We're just calculating the slope. Y2 minus Y1 over X2 minus X1. The only difference is they're telling us what X values to use. That's the only difference, okay? So we're going to evaluate the slope for a specific input value. So the first thing that we're going to do is we have to calculate what happens when I let f of x, when I evaluated f of -1. So I'm evaluating this function. F of x equals x squared plus 5. But I want to know what happens when I let x equal -1. So remember, I just replaced the x with a -1. So that's what I have. I'm trying to make it nice and big for you. So what is -1 squared? What is -1 times -1? +1. And what is 1 plus 5? So f of -1 equals 6. What does that mean in terms of an ordered pair?
-1, like that's the x value and the y value is 6.
Yeah, when my input is -1, my output is 6. That's exactly what that means, right? So there's our first ordered pair. Our next ordered pair has an input value of what? I'm circling it. What is this? 5. Yeah, we're going to input 5. So we're going to evaluate the function f of 5, which that means I replace the x with a 5. So that's 5 squared plus 5. But what is 5 squared? 25. So f of 5 is 30. But what ordered pair does f of 5 represent? It represents the ordered pair of 5, 30. Because this says when I input a 5, I get out, my output is a 30. So it's just an ordered pair. So now we're going to take those two values and do what with them? Calculate the slope, the rate of change. Yeah, using the y2 minus y1. So I'm going to label these x sub 1, y sub 1, x sub 2, y sub 2. Thank you, sir. So what is y sub 2? 30 minus what is y sub 1? Over, keep going, Kaya. What is x sub 2? And minus, perfect. Which becomes positive, thank you. So minus a negative turns into a plus. So what is 30 minus 6? 24. And 5 plus 1 is? And that reduces to what? That's it. Shh. We're not talking. Okay? So we're going to do it again using the same function, but we have two different input values. So we're just evaluating our function for the given value and turning those into ordered pairs. So what are we using as our input values? So let's start with -6. F of -6. Well, that equals -6, the quantity squared, plus 5. What is -6 times -6? It's 36. So 36 plus 5, which is 41. So f of 6 equals 41. What ordered pair is that? -6 comma 41. Good job. Okay. So what's the other input value that I need to evaluate this function as? What's the other input value? What is it? It's 4. Yeah. Need to evaluate it at 4. So f of 4 equals, well, I'm replacing x with a 4. So 4 squared plus 5. What is 4 squared? 16 plus 5 is? Okay. So f of 4 equals 21. And what ordered pair is that? 4 comma 21. So we have our 2 points. Now what do we need to do with them? Calculate the slope. y2, y1. So I'm going to label it x sub 1, y sub 1. X sub 2, y sub 2. You guys have done this enough that if you don't have to label, like if you don't need to label them, you don't have to. I just want to make sure that I'm doing that for you. So what is y sub 2? Minus, perfect, over, minus, perfect. Which does turn into a positive. -20 over 10, yeah.
Which reduces to -2. Right?
Yes, you're exactly right. Okay. So the next one that we do is with a table. And I want to show you, I feel like calculating slope with the table is much easier than using the slope formula. So we're going to calculate slope off of the table. And then the next one that gives us 2 points, we're going to set it up as a table. Because I want you guys to see what's happening. Is that okay? So for our table right here, it says in the table, which of the following gives the average rate for the interval between 2 and 6? So that's saying that when I use the input of 2 and I use an input of 6, what is my average rate of change? So I circle these, and I'm actually going to highlight them so you can see. So I just want to know, what is the change in y? What is the change in y from 9 to 3? -6. It's -6. What is the change in x from 2 to 6? It's +4. So my change in y over my change in x, I can divide both of these by, so it reduces to -3 over 2. What answer choice is that? It's answer choice 1. Answer choice number 1. Often when we talk about rate of change, it tells us how fast something is happening, and we end up finding the unit rate, which is why we do that per unit at the end. So for this example, I'm going to set up a table. Skylar is selling glasses of lemonade. G of T is the number of glasses over time. So T is my time in hours. I'm just going to make a little table for us. And I'm going to do it this way purposefully because sometimes you guys don't understand like that it works the same way, and I just want to remind you that it does. So this is really my x, and this is really my y. So my 2 input values are, well, I'm going to let t equal 2, and then I'm going to let t equal 8. And I have to plug it into this function. Okay, I have to plug it into that function. So when I let t equal 2, I end up with 2 squared plus 4 all over 2. What is 2 squared?
4.
4. And what is 4 plus 4?
8.
So when my input is 2, my output is 4. That's what that tells us. Okay, that's what that one tells us. Now let's evaluate this function again, but we're evaluating it for an input of what? 8. So 8 squared plus 4. 68 divided by 2 is 34. So when my input is 8, my output is, okay. So we're trying to find the average rate of change, and I want to show you that this works the same way. It works the same way in a table. We're just going, we always start with the y. So what is my change in y? What did I do to go from 4 to 34? Plus 30. What is my change in x? What did I do to go from 2 to 8? Plus 6. So 30 over 6 equals 5. Now remember, it says we need to write it as per. So we're selling 5 glasses of lemonade, and my time is per hour. That's no different than doing y2 minus y1. I just want to show you that sometimes it's easier to see it from a table, less math. Okay. Number 5, I think, is weird. If I gave you filled out notes, I do not like the way that number 5 is filled out in the notes. So I just don't care for that method. Let's talk about it. God bless you. I'm so sorry. So for number 5, the temperature of liquid that is being heated, has an average rate of change of 12.8 degrees Fahrenheit per minute. That is the average rate of change. So we are going to figure out a table. We're going to let t equal 3 minutes, and we're going to let t equal 8 minutes. It says, well, if the liquid's temperature when T is 3 is, so this is the temperature in degrees Fahrenheit, is 72 degrees, what is the temperature when it's 8 minutes? So here's what I want to ask you. How much time is between, what is the change in X? It's 5. So I don't know what this change is, but I know that if I take the number 5 and I multiply it by the average rate of change, I'll figure out what my y value is. I can figure out my change in y. Let's talk about why that works. Remember that the change, God bless you, in y over the change in x equals 12.8. That's what this is saying. We don't know what the change in y is, but we know that the change in x is what? We just calculated it. Is 5 minutes. So we don't know what the change in y is, but we know that the change in x is 5. So I'm just plugging it in and solving. How do I get rid of that denominator? Multiply both sides by 5. That's really what I did. Algebraically, that's what I did. In my brain, I just know that I need to take 5 times 12.8. What is 5 times 12.8? Calculator heads. Look up at the board.
5 times 8? Or 5 times 64?
It's 64. So when T equals 8, my degrees Fahrenheit equals 64. So that's not true. That's not true. The change in y is 64. Sorry. This change is 64. So what is 72 plus 64? Because we just calculated the change in y. That's what this just told us.
140?
Yeah. 140 degrees. So what we just calculated here was our change in y equals 64. So we have to end up adding that. We have to end up adding that in, okay? I think we have one more example, and it's from a graph. It's from a graph and a table. It's from a graph and a table. These are the types of questions that are I think, pretty heavy on the EOC. They give you two comparisons, and it's typically a graph and a table. And one of them is something that you're not familiar with seeing. One of them will either be a parabola or a cubic or a quartic function, something that's weird that you don't look at normally, but you're still just calculating the value at the interval. So we're finding out which function has a greater average rate of change. We're looking at this two graph and table and figuring out which one has the greater rate of change. And our interval is between -4 and +6. We're going to let x equal -4, and we're going to evaluate it when x is 6. So let's do the table first, because that's already set up for us. Oh, dang it. So when x is -4, my output is what? And when x is 6, my output is what? Let's find the change in y. What is my change in y? +6. What is my change in x? +10. Yeah, -4 + 4 gives me 0. 0 + 6 more, so this is 10. So for the function g of x, my rate of change is 6/10, which is the same thing as 3/5. How would I turn that into a decimal?
Divided by 5.
And 3 divided by 5 is?
0.6.
It is 0.6. Very good. So this decimal is 0.6, maybe. I need a new battery. 0.6. Okay. Let's look at the graph. When I let x equal -4, that's this line right here. And when I let x equal 6, that's this line right here. So I have to see where I cross my graph. And when x is -4, I'm touching my graph at what? What is my output? Do you guys see it? Yeah, it's -1. So the ordered pair -4 input gives me an output of -1. What about when I have an input of 6? When I let x equal 6, what's my output? Do you guys see how I trace that up to find the output? What is that? 4. When x is 6, my output is 4. Again, I'm going to just pretend this is a table. What is my change in y? I went from -1 to 4. What is the change in y? +5. What is my change in x? +10 again. 5/10 reduces to 1/2, or what's the decimal for that?
0.5.
So which one has a larger rate of change? The table. G of x has a larger rate of change. I'm not sure what's going on. So G of x has the larger rate of change. At the interval -4 is less than or equal to x is less than or equal to 6. At that interval. Okay. All right, so I'm going to stop